Okay, we're back and we are now on problem 1.8. Draw a line bond structure for propane, which is CH3, CH2, CH3. These are all tetrahedral, and you'll see why in just a second. The rest of the sentence here, problem here says, predict the value of each bond angle and indicate the overall shape of the molecule. Okay, so first we're just going to draw a line bond structure for this here. And let's get started with the carbon, of course, all three carbons in the center. And we've got these three hydrogens right here now. We've got a hydrogen, and a hydrogen. This angle, because it's tetrahedral, remember, you're including this carbon in this entire thing, and that's why they're saying it's tetrahedral. It's 109.5 degrees. Then we've got a hydrogen on bottom and a hydrogen on top, and then we just replicate what we have on the right, on the left. Same thing. This is a tetrahedral, and this here is 109.5 as well. This carbon in the middle is a tetrahedral because you've got a hydrogen here and you've got a hydrogen down here. You've got a carbon to the left and a carbon to the right, and that is why this is a tetrahedral. So all of these are tetrahedral. This entire thing, all three of these, the CH3, the CH2, and the CH3, tetrahedral. One way to remember if you're taking a test or something and you can't remember the bond angle, one way to remember is just remember that the more that you have, the more bonds, the less the angle is. And that makes sense, right? Because if you've got, let's say, a tetrahedral compared to a trigonal planar like this, that would be a trigonal planar. Well, you've obviously got more space in between here, and that's about 120 or so degrees. This is 109.5 degrees. So, again, the more elements, I guess you have, the lower the bond angle. The less elements, the higher the bond angle. Okay? So that takes care of that part. Let's go on now to, well, what have we done so far? We've drawn it out, we've figured out the bond angle, and now let's figure out the overall shape. Okay. So we've got a carbon, and on top of this carbon, we have two hydrogens, this hydrogen and this hydrogen. This one here and this one here. From there, we go like, whoops, that's actually going to be a carbon as well. We go carbon, carbon, and then this is a CH3, which means we have our three hydrogens. And the electronegativity, why is this structure the way it is? I think, well, I know hydrogen is a 2.1 electronegativity. Carbon is actually what? Hydrogen, I think, is 2.5. And carbon, I believe, is 2.1, although I'm not entirely sure, which doesn't explain then why it is in the shape it is in. So I'm going to leave the electronegativity out of it right now, and I'm going to stop here because we have answered the question, and that's it. So we'll see you on the next video.